Hello everyone, I'm Guzan from Group 5 and my teammates are Komiyang, Tujixian and Yuweixian. Today we'll be discussing the topic of normalization. So what is normalization? Normalization is defined as the process of organizing data in a database to minimize redundancy and dependency issues by dividing a large table into smaller related ones. It aligns with relational theory to ensure data integrity and makes updates uh, creates more efficient. Normalizations progress through stage called normal forms, such as 1NF, 2NF, 3NF, and so on. Next is role of normalization in database design. Normalizations play a virtual role in database design by ensuring efficient and logical data organization. It structures the database to reduce redundancy, eliminating duplicate data to save space and simplify maintenance. By maintaining data integrity, normalization ensures consistency and accuracy across the database. It also addresses anomalies such as insertion anomalies, update anomalies, and deletions anomalies. Additionally, normalization facilitates scalability, making the database design adaptable to future growth and evolving requirements.
I'm Koming. I'm going to present about the overview of normal forms. The rules for first normal form must ensure each column contains only a single value. The data must have primary key to ununique identify each row and use separate rows for each instance of multi-value attributes. As you can see, the table shows the multi-value data is separate to new row. Next, for the second normal form, the table must first satisfy all the rules of 1NF to qualify for 2NF. It depends on only portion of primary key with no attribute. Each component will become key in the new table. Here is the result for each component form for a new table. After second normal form is third normal form. The table must be in 2NF, only then will be converted to 3NF. Ensure that there are no transitive dependencies to improve data integrity to prevent inconsistency by maintaining data in one place. This creates a transitive dependency employee ID to department ID to department name. In the result, after table is converted to 3NF, it's split into two separate tables. That is employee table and department table.
Now I'll discuss how normalization and ER modeling work together to design better databases. You start with an ER diagram, which called ERD, identifying entities, attributes, and relationships, then apply normalization to refine the structure and eliminate anomalies. This ensures entities meet normal forms before creating tables. While challenging to separate normalization from ER modeling, combining them helps prevent issues like redundancy and poor design common in real-world databases. So now I'll explain the process of combining normalization and ER modeling in three steps. So the first step, we start with an initial ER diagram. We begin by identifying entities, attributes, and relationships. So for example, here has the student contain student ID and student name. Course contain course ID, course title, and course fee. We define primary keys and relationships like the many-to-many relationships between student and course. So step 2, we need to normalize the data. We apply normalization rules to remove redundancies and resolve partial and transitive dependency. To manage the many-to-many relationships, we introduce a new entity which called enrollment, which links students to course and include attributes like enrollment date. The updated structure becomes student, course, and enrollment. So the last step, which is step 3, we revisit the ER diagram. We update the ER diagram to reflect this change. The enrollment table resolves the many-to-many relationships, while student and course store data specific to their roles, ensuring the design aligns with business rule.
Hi everyone, today I will discuss the denormalizations, a technique used to improve database performance. The importance of normalizations is ensures data consistency and reduce redundancy, but it increase the numbers of tables, which can slow down system performance. So now I will make a conclusions about normalizations in database design. Normalizations ensures database are organized, free from redundancies, and consistent. It addresses anomalies, enhances scalabilities, and support efficient data retrieval, making it essential for reliable and scalable database system.